I know a lot of you might be wondering, Scott, why do I need to do all this crazy algebra just to solve for currents? Isn't there like that little gadget that with the two little electrodes and you just like touch the circuit and it tells you how much current's moving or how much voltage the circuit has? And the answer is yes. For a circuit that you've already built and is already running, you can measure the current. But if a circuit hasn't been built yet and you want to figure out how much current is going to go through different sections, and you just have a design, then you need to actually calculate how much current will be going through each segment of a circuit. But once the circuit's made, heck yeah, there are several devices that we can use to measure different qualities of a circuit. The first of those is called an ammeter, and it measures current. Not surprisingly, it measures amps, ammeter, amps, ammeter, right? So imagine you have a totally simple circuit, right? Battery and one resistor. About as simple as you can get, right? And we want to measure the current in that circuit. Okay, well, the device is called an ammeter, and it has a symbol like this. Not very surprising, right? The key to an ammeter is that if you're measuring the current, it actually has to be in series with the resistor, right? So if you're measuring the current in some segment or some loop of a circuit, it has to be in series with that loop, all right? So what I mean by that? I mean, you couldn't take the two ends, the two electrodes of an ammeter and attach them like that. You're not going to be able to get the current that way because the current needs to be because the ammeter needs to be in the circuit so that the current flows through it, all right? The whatever current is in the series, it's going to flow through it, okay? So in order to not disrupt the voltage in the current that the voltage that the battery is putting out, right? In order not to disrupt that, the ammeter has to have very, 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 very low resistance, almost zero resistance, right? Because imagine if this did have a significant resistance, then you have to add these together. That seriously changes the resistance, which will change the current. So you couldn't measure the current because just by adding it, you're changing the current, right? So in other words, an ammeter has to have very, very low resistance. And what would happen if you had something with really, really low resistance that's put over here on the other sides of this resistor? Well, current loves to travel in the path of least resistance, so you wouldn't even be getting any more current passing through the resistor. It would all go through the ammeter, and you would basically get an infinite current, all right? So all of this is to say, or to justify, that an ammeter has to be in series, has to be actually a part of the circuit in order for you to measure the current in it, okay? That's the key for the ammeter, all right? Now, the voltmeter, as you would expect, is a little bit different, okay? If you want to measure the voltage drop between 2 points in a circuit, okay, you have to use something called a voltmeter, and that has this symbol on it, all right? And unlike a ammeter, right, you need to have it be in parallel with the circuit, okay? So if I want to find out how much voltage is dropped when I hit this resistor, right? So you have, current coming out and it drops off a certain potential and then it goes off here to the lower potential, right? If I want to find out how much voltage difference there is between the beginning and the end of this resistor, in other words, what's the voltage drop across that resistor, right? Then I have to put the voltmeter on opposite sides of the resistor, and that'll tell me the potential difference. So, for example, this is a 12-volt battery, right? We know from Kirchhoff's loop law that 12 volts would have to be dropped off over here too, right? So that there's a net zero delta V across the entire circuit, right? Remember that from a couple of videos ago? So that means that 12 volts minus the 12-volt drop here ends up being 0, right? So the voltmeter then will register, blah, 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 circle dial, blah, 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 12 volts. Okay? All right. So those are the two biggest tools that scientists use to measure elements of a circuit. And just FYI, you might have known that the most common use, at least for households, for a voltmeter, is to check the quality of batteries. Okay, so for example, if I have a battery here, right? Let's say it's a AA battery, right? And I want to find out, you know, how strong is it? Is it still fully powerful? They should be 1.5 volts, right? So then I would put this across. I put a voltmeter from the beginning to the end, and this will give me the delta V between the tip of the battery to the bottom of the battery. And if it's a good battery, it should read 1.5 volts. If it's a bad battery, it's going to be seeping down below that. Okay? So that's a fun trick that now you know how it works in your own house if you want to check your batteries. So the last device that I want to talk about here is the multimeter. And the multimeter just combines the ammeter, the voltmeter, and an ohm meter, which measures resistance, all into the same device. So you can just crank the dial, turn the dial to whatever you want to find. One of the sad facts of this being an online course is you don't get to play with these, although you could for your Mythbusters project if you would like to. So I encourage that. But normally there's several labs where you actually get to see the voltage drop across certain resistors and how much current is in a circuit. And unfortunately with online courses that's not possible. But if you have one of these at home, I would just play with it. Just get out a battery, maybe attach a battery and a light bulb and play with it and just see what you can learn. All right? All right.